Hi, I'm Mr. B at the Phoenix Learning Center. During this lesson, I will explain how to perform simple metric conversions. You know, the simplicity of the metric system stems from the fact that there is only one unit of measurement, or base unit, for each type of quantity measured. Each subsequent quantity is a tenfold increase of the previous quantity. The three most common base units in the metric system are the meter, the gram, and the liter. To simplify things, very large and very small objects are expressed as multiples of 10 of the base unit. In other words, if you can multiply by tens, then you can perform any metric calculation. This chart shows the relationship between the various prefixes, fractions, decimals, and scientific notation as related to the metric base units. For example, a kilo represents 1,000 base units, and a milli represents 1,000th of a base unit. In general, as a chemistry student, you will most likely encounter the quantities listed on this chart. But if you are an advanced chemistry student, you may encounter larger or smaller quantities. However, the basic principles required to perform the calculations will be the same. The first step in performing metric conversions is to write out a simple metric scale, placing the base unit, or BU, in the middle. Multiples and fractions of these base units are created by adding prefixes to the names of the base units. These prefixes denote powers of 10 so that the metric system, or the metric units, are always divided by tens, hundreds, thousands, etc. Each move to the right on the scale represents a 10 times smaller amount than the previous amount. For example, centi amounts are 10 times smaller than deci amounts. So when converting deci amounts to centi amounts, multiply by 10. Each move to the left on the scale represents a 10 times larger amount than the previous amount. For example, deci amounts are 10 times smaller than base units. So when converting deci amounts to base units, divide by 10, or multiply by the reciprocal of 10. In general, when moving to the right on the scale, multiply by tens, and when moving to the left on the scale, divide by tens or multiply by the reciprocal of tens. The metric scale is similar to a map. There is an origin and a destination, except that this map has but two possible directions, to the left and to the right. Now for some practice. Consider the following example where we're asked to convert 1 hectometer to decimeters. Okay, the first step is to write a simple metric scale, placing the base unit, or BU, in the center. Now eliminate the unneeded portions and set a destination and an origin. In this case, the destination will be deci, and the origin will be hecto. In order to go from hecto to deci, we must pass deca and the base unit. Remember, each prefix is separated by 10, so in this particular case, we must multiply by 10 3 times, since we're going from left to right. This represents the numerical setup for calculating the answer, where we may write 1 hectometer times 10 decameters per hectometer times 10 meters per decameter times 10 decimeters per meter. And after canceling the units using dimensional analysis, also known as the factor label method, the answer is 1,000 decimeters. In this example, we're asked to convert 0.5 grams to kilograms. Once again, we first write a simple metric scale, placing the base units in the center. and eliminating the unneeded portions. Now set the destination and the origin. This time the destination is kilo and the origin is the base unit grams. In order to go from the base unit to the kilo, we must pass the deca and the hecto. This time, however, we're going from right to left on the scale. So now we divide by tens or multiply by the reciprocal of tens. So now we divide by 10 3 times. The numerical setup for calculating the result is written as follows, where we multiply 0.5 grams times 1 decagram per 10 grams times 1 hectogram per 10 decagrams times 1 kilogram per 10 hectograms. After canceling the units, the solution may be rewritten as follows, where we multiply 0.5 times the reciprocal of 10 times the reciprocal of 10 times the reciprocal of 10. And simplifying further, we may write 0.5 times 1 over 1,000, or simply 0.5 divided by 1,000. At any rate, the answer will be 0.0005 kilograms. In this example, we're asked to convert 1,750 milliliters to liters. Okay, step 1. Write the simple metric scale, placing the base unit in the center. Eliminate the unneeded portions, set the destination and the origin, where the destination will be the base unit liter, and the origin will be milliliters. In order to go from milli to the base unit, we must pass centi and deci. We're again going to the left, which means we divide by tens or multiply by the reciprocal of tens. In this case, we divide by 10 3 times. The numerical setup for calculating the answer is written as follows, where we multiply 1,750 mLs times 1 centiliter per 10 milliliters times 1 deciliter per 10 centiliters times 1 liter per 10 deciliters. After canceling the units, we may rewrite the solution as follows, where we multiply 1,750 times the reciprocal of 10 times the reciprocal of 10 times the reciprocal of 10. Or we may multiply 1,750 times 1 over 1,000, which is equal to 1,750 divided by 1,000. At any rate, in this case, the answer will be 1.75 liters. Some students may wonder why I use so many steps to solve these problems. The answer to that question is quite simple. Learning involves repetition. The more times a concept is repeated, the more completely the concept is understood. This concludes my lesson on how to perform simple metric conversions. If you're watching this lesson on YouTube, there is a longer version that includes more practice exercises on my Facebook page at facebook.com/WPHS Chemistry. And if you would like to make a donation to help offset the costs of producing these educational videos, go to GoFundMe at gofundme.com/FAW9T82C. Thanks for watching.